Hello dear student, welcome to your new session of Newton's laws of motion. It's your fifth lecture. In last lecture we'll discuss about normal reaction force, how to solve the numericals of normal reaction force. Now in this topic, in this session, we'll discuss about acceleration and tension on pulley block system. Acceleration and tension on pulley block system. It will be look like this. Let's suppose this is a ceiling, a pulley is there in which two masses are present. Let's suppose first mass is considered to be M1 and second mass is considered to be, my dear student, M2. So we have two masses. Let's suppose M1 is greater than M2. If M1 is greater than M2, it implies M1 goes down with acceleration A, and we already discussed about this is a fixed pulley block system, my dear student. This is your fixed pulley block system. Remember, this is our fixed pulley block system. So in fixed pulley block system, the acceleration on both the side of pulley remains same. I'll write here, in fixed pulley block system, in fixed pulley block system, acceleration, velocity and displacement on both side of pulley remains same. Remember this thing, in fixed pulley block system, acceleration, velocity and displacement on both side of pulley remains same. So if this mass is moving down with acceleration A, then this mass must move with same acceleration, but the direction of acceleration, it is but obvious that if mass is moving down, then this mass moves up. The thing is, acceleration on both side, velocity on both side and displacement on both side of pulley remains same. Remember, if pulley is fixed pulley. And what actually fixed pulley is? Now see, my dear student, this block are performing motion like this. This M2 moves down and M1 moves down and M2 moves up. So these blocks are performing motion like this. So if blocks are performing motion, the pulley cannot move like this or cannot move like this. So we'll say pulley is fixed, although the blocks are performing motion. So with respect to block, if pulley remains at rest, then the pulley is considered to be fixed pulley block system. So in this topic, my dear student, we have to find the acceleration in pulley block system. And second, if this is a rope, remember this is a rope, a single rope is there, then we know that on rope there is a force called tension. What is the value of tension in this rope? We have to find the value of tension on this rope and acceleration on both sides of the pulley. This is our topic, acceleration and tension on pulley block system. And remember, pulley block means fixed pulley block system. So some important points are there which you have to understand, my dear student, before solving the derivation, or we can say concept. First thing is, pulley is always considered to be massless. See here, this is a pulley. This pulley is always considered to be massless. We cannot consider the mass of pulley. And remember one thing, my dear student, a pulley, the work of pulley is to rotate. But if the pulley is massless, then pulley is not able to rotate. On pulley, the rope will slides. Remember this thing? In our syllabus, pulley is always massless. And if pulley is massless, then pulley cannot rotate. Over the pulley, the rope is always sliding. So remember this thing, we cannot consider the weight of pulley because the mass of pulley is negligible in pulley block system. First thing. Second thing, rope is always massless. The rope which we'll consider, this is a rope, this rope is massless And if rope is massless, then tension on each point of rope remains same. What this implies, see, let's suppose we have a rope like this. Let's suppose this is a rope and this rope is massless. This rope is, my dear student, massless. So if rope is massless, then remember one thing, I'll mark a point A, a point B and a point C on this rope. If rope is massless, then tension at point A, tension at point B and tension at point C remains same. That means each point on the rope carry same tension if the rope, my dear student, is massless. So remember this thing, if rope is massless, then tension on each point of the rope remains constant, or we can say remains same. Tension on each point of the rope remains same. That what I'll write here is rope is massless, tension on each point of rope remains same. Third thing which you have to remember is pulley is frictionless. No any friction is present on pulley. Pulley is smooth. No friction is there. So don't ever think about frictional force if we are dealing with pulley block system, and if pulley is, my dear student, fixed pulley. So three important points are there which you have to understand to solve the question, or we can say to understand the concept. First thing is pulley is always considered to be massless. We cannot consider the mass of pulley, hence its weight is not eligible. We cannot think about its weight. Second thing is rope is always massless, and remember this is very important point, my dear student. If rope is massless, then tension on each point of the rope remains same. Every point carries same value of tension throughout the rope if rope is massless. Third thing is pulley is frictionless. So if pulley is frictionless, then there is no any role of friction when we are talking about pulley block system. Okay, so let's start finding the acceleration of pulley block system. Acceleration of pulley block system. So write down case first. Acceleration of blocks, acceleration of block. Write down case first, acceleration of the block. So we are now discussing about acceleration of the block, my dear student. So see, this is a fixed pulley block system. In fixed pulley block system, as I already tell you, acceleration on both sides remains same. We are consider M1 to be greater mass and M2 be lower mass. So if M2 is greater compared to M1 is greater compared to M2, then it is but obvious that M1 goes down and M2 goes up. If M1 goes down with acceleration A, then M2 goes up with acceleration A. So try to make case first. I am finding acceleration of blocks. So make the FBD. I'll make the FBD of M1. See, M1 is moving down with acceleration A. If mass is M1, then we know that weight is there, that is M1g. And see, here we have a rope like this, and this rope is massless. So if this rope is massless, then tension on each point of rope remains same. So if tension in this side is T, then in this side also the value of tension be T, because tension remains constant throughout the rope if rope is massless, and we are considering massless rope. So my dear student, we know that tension is a force which is present on string, rope, and it is always a pulling force, and it always made away from the body. So let's make it away from the body. So tension is away from the body. Now see, my dear student, two forces is acting. One is in downward direction, that is weight of the block, and one is tension which is in upward direction, and acceleration is in downward direction. So let's write the equation. It is F net is equals to ma net. F net means bigger force minus smaller force into ma net. Now see, my dear student, bigger force is m1g, because in the direction of m1g acceleration is there. So m1g minus t is equals to m1a. So this is our first equation. Let it to be equation number 1. Now moving forward, my dear student, let's make FBD of M2 block. So FBD of M2 block, it is, here comes M2, vertically downward weight, that is M2G. Now see, my dear student, M2 is again connected with a string in which tension is T, and the M2 is moving in upward direction, as we'll consider M1 is greater than M2. Means the acceleration is in upward direction, and there is a force more called tension, as the string is connected with M2 as well, and we know that tension is a pulling force which always made away from the body. So let's make the value tension, it is T, and acceleration is in upward direction. Now see, there is two forces which is acting along the direction of acceleration. One is in upward direction and another is in downward direction. So again we have to find F net. So F net is equals to ma net, and meaning of F net is bigger force minus smaller force is equals to ma net. Minus can be done if forces are in opposite direction. What if forces are in same direction? If forces are in same direction, dear students, then the forces will be added. So moving forward, bigger minus smaller, it is T minus M2G is equals to M2A. So this is our equation number 2. Now we have to add equation 1 and equation 2. So add equation 1 and equation 2. Add equation 1 and equation 2. It is m1g minus t is equals to m1a plus t minus m2g is equals to m2a. Now see, dear student, t get cancelled and we have to add both the equations. So it will be m1g minus m2g is equals to m1a plus m2a. So what we'll get, dear student? We'll get, take common acceleration, take acceleration common. So we'll get, let's see, it is m1g minus m2g is equals to m1a plus m2a. So m1g minus m2g is equals to m1 plus m2 into a. So a becomes equals to m1g minus m2g upon m1 plus m2. If we'll take g common, it is a is equals to m1 minus m2 into g upon m1 plus m2. So this is the value of acceleration in fixed pulley block system. Both the blocks carry same acceleration. It is m1 minus m2 into g upon m1 plus m2. Remember, dear student, the acceleration on both sides of pulley remains same. Now see, my dear student, you don't have to learn like this. It is m1 minus m2 into g upon m1 plus m2. You have to learn like this. The value of acceleration, as we know, m1 is greater than m2. It means m1 is bigger mass compared to m2, which is smaller mass. So you have to learn the formula like this: mass of bigger minus smaller block mass into g upon mass of bigger plus mass of smaller. You have to learn this formula like this. Remember, acceleration is equals to bigger mass minus smaller mass into g upon bigger mass plus smaller mass. I hope you all understand how to find the value of acceleration. Now it's turn to find the value of tension, my dear student. So take any one equation. Either you have to take equation first or you have to take equation second. It is up to you. So let's take equation number 2. So I'm taking equation number 2 for finding the value of tension. So write down case 2, tension. Write down case 2, tension. So now we are discussing about tension. tension on string. So see dear student, from equation second, I am taking equation second, it is T minus M2G is equals to M2A. So let's take M2G this side. So T is equals to M2A plus M2G, or we can write it as T is equals to M2G plus M2A. Now we know the value of acceleration. Acceleration is equals to M1 minus M2 into G upon M1 plus M2. Put the value of acceleration in this equation. So it is T is equals to M2G plus M2, and the value of acceleration is M1 minus M2 upon M1 plus M2 into G. So this is the value of acceleration which we'll put. So let's take common M2G, my dear student. Common, we'll take common M2G. So what we'll get? T is equals to M2G get common. What we'll get? Plus here it is M1 plus M2 because we have to cross multiply the term. So M2G taking common. So what we'll get? Here comes 1 and it will be M1 plus M2, M1 plus M2 plus M1 minus M2 divided by M1 plus M2. I hope you all understand. M2G is taken common, so here it will be 1. So M1 plus M2 plus M1 minus M2. M1 minus M2. Now see, 1 M2 is plus, 1 M2 is minus. So M2 get cancelled. M1 plus M1. It is 2 M1. So what we'll get, my dear student? We'll get T is equals to try to find by your own. So it is T is equals to M2G, and here it is M1 plus M1. It is 2 M1 upon M1 plus M2. So what we'll get? T is equals to 2 M1 M2G upon M1 plus M2. So this is the value of tension which is present in string in fixed pulley block system, and this is the value of acceleration in fixed pulley block system. So the value of acceleration is A is equals to mass of bigger block minus mass of smaller block into G upon mass of bigger block plus mass of smaller block, and the value of tension is T is equals to 2 M1 M2G upon M1 plus M2. So I hope you all understand this concept. On this concept, let's make some numericals. So write down, find the value of, write down the question, find the value of acceleration, find the value of acceleration. See, if you are not aware with the formula, you can solve the question by using concept as well. But if you learn the formula, then it is easy. You have to just put the value and you will get answer. Otherwise, if you are not aware with formula, still you can solve the question, but with logic, that is with free body diagram. So write down, find the acceleration, find the acceleration and tension, find the acceleration and tension in the string, find the acceleration, find the acceleration and tension in the string, find the acceleration and tension in the string. Let's suppose the system is like this. This is a block of mass 2 kg and this is the block of mass 4 kg. So it is but obvious that this mass is greater than compared to 2 kg. So it is but obvious that 4 kg moves down with acceleration A and 2 kg moves up with acceleration A. So try to solve the question, my dear student. So acceleration is nothing but mass of bigger block minus mass of smaller block into G upon mass of bigger plus mass of smaller. So bigger mass is 4. So 4 minus 2 into g is 10 upon 4 plus, my dear student, 2. So acceleration is 4 minus 2 is 2, 2 into 10 is 20, 20 by 6, 2 3s are 6, 10. So A is equals to 10 by 3 meter per second square. This is the value of acceleration. It implies 4 kg moves down with acceleration 10 by 3 meter per second square, and 2 kg moves up with acceleration 10 by 3 meter per second square. Moving forward, my dear student, let's find the value of tension. So tension is nothing but 2 m1 m2 g upon m1 plus m2. So T becomes equals to 2 m1. m1 is 2 kg, m2 is 4 kg, g is 10 upon m1 plus m2, it is 4 plus 2. So T becomes equals to 2 2s are 4, 4 4s are 16 into 10, that is 160 divided by 4 plus 2 is 6. So 2 3s are 6, 2 8s are 16. So tension becomes equals to 80 by 3 Newton. This is the value of tension and this is the value of acceleration. Simple. You have to identify which mass is bigger, which mass is smaller. Apply the formula. It is mass of bigger minus mass of smaller into g upon mass of bigger plus mass of smaller. The formula of tension is 2 m1 m2 g upon m1 plus m2. Moving forward, my dear student, let's practice one more numerical. Write down, find the acceleration and tension. Find the acceleration and tension. Find the acceleration and tension on the string. Find the acceleration and tension on the string. Find the acceleration and tension on the string. So see, my dear student, the question is like this. We have to find acceleration and second tension present on string. Let's suppose the system is like this. One block is of mass 4 kg, another block is of mass 8 kg. So it is but obvious that 8 kg carry maximum mass compared to 4 kg. So 8 kg goes down with acceleration A and 4 kg moves up with acceleration A. Now we know that acceleration is equals to mass of bigger minus mass of smaller into g upon mass of bigger plus mass of smaller. So what we'll get? Bigger mass is 8. So 8 minus 4 into g is 10. The value of g is approximately 10. Otherwise, its exact value is 9.8 meter per second square. But we'll take 10. Mass of bigger 8 plus 4. So A is equals to 8 minus 4 is 4 into 10 divided by 8 plus 4 is 12. So A becomes equals to 40 by 12. So 2 6 are 12. 2 2s are 4, 20, 2 3s are 6, 10. Acceleration becomes equals to 10 by 3 meter per second square. I hope you all understand. Moving forward, apply the formula of tension. So tension is nothing but 2 m1 m2 g upon m1 plus m2. So tension becomes equals to m1, that is 8 into 2 into 10 divided by 8 plus 4. So T is equals to 8 2s are 16, 16 2s are 32, multiply by 10 divided by 8, 12. So T becomes equals to 320 by 12. So 2 6s are 12, 2 1s are 2, 6 are 0. 2 3s are 6, 2 8s are 16. Tension becomes equals to 80 by 3 Newton. So I hope you all understand how we'll get the value of tension and how we'll get the value of acceleration. Remember the formula? The formula of acceleration is mass of bigger block minus mass of smaller block into g upon mass of bigger block plus mass of smaller block. Similarly, the formula of tension is T is equals to 2 m1 m2 g upon m1 plus m2. Remember the formula. Now moving forward, my dear student, let's make one more numerical, but this numerical is quite different compared to these two what we'll solve. if we have two blocks in one side, then how to find the value of acceleration and tension? So write down, find the value of acceleration, find the value of acceleration, find the value of acceleration and tension, find the value of acceleration and tension on the strings. See, now the question is like this, my dear student. Let's suppose in this side we have a block of mass 2 kg, and in this side we have a block of mass 2 kg. Along with this there is one more block of mass, again let's suppose 2 kg. So here comes two different blocks in one side and one block is in another side. See, my dear student, here we have two different strings. One string is this and another string is this. So we know that if strings are different, then tension is also on both string is different. So let's suppose in this string tension is T1 and in this string tension is T2. Now see, my dear student, this string is same in this side as well. So if in this side tension is T2, then in this side tension is again T2, because we know that we are considering massless string and massless string carry equal tension in each point, dear student. So in this rope the tension is T1 and in this rope the tension is T2. If in this side tension is T2, then it is but obvious in this side tension is again T2. Now see, my dear student, you have to find, in question they are saying find first part T1, second part T2 and third part acceleration. See, finding acceleration is easy. For finding acceleration you have to apply formula, but in this situation, my dear student, the formula of tension is not applicable. Remember this thing, if multiple ropes are present on single system, then you cannot apply the formula of tension. You can apply the formula of acceleration as well, but you cannot find the tension with the help of formula, which is T is equals to 2 T1 T2 T is equals to 2 M1 M2 G upon M1 plus M2. This is the formula of tension, but this formula is not applicable if more than one rope is present. So here more than one rope is there, my dear student. You have to apply acceleration. For acceleration, we know that the value of acceleration is mass of bigger block minus mass of smaller block into G upon mass of bigger block plus mass of smaller block. This is the formula of acceleration. We are aware with this. See, consider both the blocks to be a single mass. In these types of question, if you want to apply the formula of acceleration, because we know that this is a fixed pulley and in fixed pulley acceleration on both sides remains same. In this situation, in this side, total mass is 4 kg. Remember, you have to apply the formula of acceleration in any circumstance, but you cannot apply the formula of tension if more than one rope is present. Remember this thing. So what you have to do, consider both the blocks to be a single block and calculate its total mass. It is 4 kg and is in this side the mass is only 1, it is 2 kg. So what it implies, this mass is greater than this side mass. So this system goes down with acceleration A and this system goes up with acceleration A. As fixed pulley is this is a fixed pulley, hence both side acceleration remains same. So the formula of acceleration is mass bigger. Bigger means total mass of these two blocks. It is 4. So 4 minus mass of smaller block, it is minus 2. G is 10 upon 4 plus 2. So acceleration is equals to 4 minus 2 is 2 multiply by 10. 4 plus 2 is 6. So acceleration is 20 by 6. 2 3s are 6. 10. So acceleration is 10 by 3 meter per second square. It implies the acceleration in this side is 10 by 3 meter per second square, as well as in this side it is 10 by 3 meter per second square. Now see, my dear student, if you wish to find the value of tension, then you have to go with free body diagram, dear student. So let's make free body diagram of this 2 kg block. So this is your 2 kg block and mass is 2 kg, so its weight must be mg, that is 20, because the value of g is 10, so it will be 20, and its acceleration is downward side and it is 10 by 3 meter per second square. Now see, this 2 kg mass is connected with a string in which tension T1 is present. So tension is a pulling force, it always made away from the body. Now see, apply F net. So F net is equals to ma net. F net means bigger force minus smaller force into ma, that is 10 by 3. So bigger, the acceleration is in downward direction, it means 20 is greater than T1, because in the direction of acceleration 20 is there. So we'll write mg minus T1 is equals to m is to 10 by 3. So mg means 20 minus T1 is equals to 20 by 3. So T1 becomes equals to, it's minus and it is 20 by 3. This 20 comes this side, so it will be minus 20. So try to solve this, you'll get your answer as in form of T1. Moving forward, my dear student, if you wish to find T2, then the value of T2 becomes, draw the FBD. For finding T2, you have to draw the FBD of this block, or you can make the FBD of this block as well. But if you are making the FBD of this block, then you have two different tensions. One is in downward direction, that is T1, and other is in this direction, that is T2. But if you prefer this 2 kg FBD, then only one force is acting on this kg, only one tension is acting on this 2 kg, it is T2. So moving forward, my dear student, now we have to find the value of T2, 2 kg, so it is mg, acceleration is in upward direction, it is 10 by 3, and T2 is a pulling force, tension is a pulling force, so it is away from body. Now see, acceleration is in upward side, T2 is also in upward side, so we'll apply F net is equals to ma net. F net means bigger force minus smaller force is equals to ma. So T2 minus mg is equals to m into 10 by 3. So T2 minus 20 is equals to 20 by 3. So T2 equals to 20 by 3 plus 20. You'll get the value of T2. Through this, you'll get the value of T1. I hope you all understand how to solve these types of questions. So moving forward, my dear student, let's practice some more question. Let's suppose the system is like this. Write down, find the value of tension T1, find the value of tension T1, T2, find the value of tension T1, T2 and acceleration. Find the value of tension T1, T2 and acceleration. Find the value of tension T1, T2 and acceleration. So see, my dear student, it is like this. Let's suppose on both sides, now two blocks are there. The figure is like this. On both sides, two blocks is present. Or we can consider, yes, we can consider two blocks are there. So in this rope, tension is T1. This is a single rope. So if in this side T2 is there, then in this side also T2 is present. In this rope, let the tension is T3. Now if I'll take mass, let's suppose this is 2 kg, this is 1 kg, let's suppose this is 4 kg and this is again, let's suppose 1 kg. So we have to find first part T1, second part T2 and third part T3, fourth part acceleration. As I already tell you, don't worry at all if multiple blocks are there. Apply the formula of acceleration, but yes, we cannot find the value of tension through formula, but we can find the value of acceleration with the formula. The acceleration formula is mass of bigger block minus mass of smaller block into g upon mass of bigger block plus mass of smaller block. First you have to consider both the masses to be a single mass. So these two masses is considered to be single mass, and these two masses is also considered to be single mass. So in this side total mass is 3 kg, and in this side total mass is 4 plus 1, it is 5 kg. So it is but obvious that 5 is bigger than 3. So this system goes down with acceleration A, and this system goes up with acceleration, dear student, A. Now apply the formula of acceleration. So the formula of acceleration is mass of bigger minus mass of smaller into g upon mass of bigger plus mass of smaller. So bigger mass is 5 minus smaller mass is 3 into g is 10 upon 5 plus 3. So 5 minus 3 is 2, 2 into 10 upon 5 plus 3, 6, 7, 8. So it is A is equals to 20 by 8. So 2 4s are 8, 10. 2 2s are 4, 2 5s are 10. Acceleration becomes equals to 5 by 2 meter per second square. I hope you all understand. You have to consider both mass to be together, and in this side also both mass to be considered together. This side total mass is 5 kg. In this side total mass is 3 kg. So it is but obvious that this side mass is greater than this side mass. So this mass, if it is greater, then this moves down and this moves up. So mass of bigger minus mass of smaller into g upon mass of bigger plus mass of smaller. Now make the FBD for finding the value of T1, T2 and T3. So I am finding the value of T1. So for T1 I will make FBD. It is 1 kg. So mg is vertically down. We will write it as 1 into 10. Acceleration is upward side and its value is 5 by 2 meter per second square. Now see, this 1 kg is connected with a rope having tension T1, and we know that tension is always a pulling force which always made away from the body. So let's make tension to be away from body. It is like this, T1. Now see, two forces are there along the direction of acceleration. We have to find net force. So F net is nothing but equals to ma net. F net means bigger minus smaller into ma net. Bigger force is T1, smaller force is mg is equals to m into 5 by 2. So T1 minus mg, that is 10, is equals to 1 into 5 by 2. So T1 minus 10 is equals to 5 by 2. So T1 is equals to 5 by 2 plus 10, my dear student. So T1 becomes equals to 5 plus 10 by 2 Newton. This is the value of T1. Moving forward, calculate the value of T2 as well. For finding T3, let's find first T3. So the value of T3, for finding the value of T3, we have to make the FBD of this 1 kg block. So for T3, this is our block of mass 1 kg. Vertically downward it is mg, and in upward it is T3, and acceleration is in downward direction, and it is 5 by 2. So 5 by 2 meter per second square. So F net becomes equals to ma net. F net means bigger force minus smaller force is equals to ma net. Bigger force must be mg minus T3 is equals to ma, that means 5 by 2. So mg is 10 minus T3 is equals to 5 by 2. So minus T3 is equals to 5 by 2 minus 10. After solving this, you will get the value of T3. Similarly, if you wish to find the value of T2, you have to make FBD of this side or this side. Whatsoever you will prefer, you can. So for finding T2, we have to make FBD of this 2 kg block. So this is 2 kg, vertically downward mg, acceleration is in upward direction, and see my dear student, this 2 kg is connected with two different ropes. in which tension T1 and T2 is present, and we know that tension is always a pulling force. So T2 comes this side and T1 comes this side, and acceleration is in upward direction. So my dear student, bigger F net is equals to ma net. F net means bigger force minus smaller force is equals to ma net. See, bigger is T2 and in downward direction two forces are there. One is T1 and other is mg. So we'll write it as T2 minus T1 plus mg is equals to ma net. So with this equation, you will get the value of T1, put the value of T1, put the value of mass, you will get your answer. So I hope you all understand the concept of fixed pulley block system in terms of acceleration and tension. It is very easy, my dear student, to solve these types of numerical. Just revise the video, make proper notes and go ahead with numericals. Simple, we have two different formula and one basic concept, that is, if rope is massless, then tension on each point of rope is same, first thing. Second thing, the value of acceleration is mass of bigger minus mass of smaller into g upon mass of bigger plus mass of smaller, and the formula of tension is 2m1 m2 g upon m1 plus m2. So I hope you all understand this video. Make your proper notes. In next class, we'll start with new topic, that is motion on double inclined plane. So thank you so much, my dear student, with connecting with me. So stay happy, stay safe, stay in your home and study hard. Thank you.